Alright, in this video I'll be helping you get started on analyzing and solving polynomial equations. So what we need to focus on is understanding that we may have real or complex zeros. So what we need to first do is graph our function. So I highly recommend you, for every single one of these, type them in y equals first. Now some of them, hopefully you recognize that you might be able to factor. We did this one in class today by factoring. But sometimes I want to show you how to do it if you aren't good at factoring. When we graph the function, we can see that it appears to cross at -3 and +3. We can verify that on our table by checking our table, and indeed we have -3, 0 and +3, 0. So far, for number 1, I know that two of my answers are -3 and +3. But what I also know is that my degree is 4. If my degree is 4, I should end up with 4 solutions. So how do we go about finding the other solutions if it only crosses the x-axis 2 times? Well, we should recognize that we've got 2 real rational roots. That means the other 2 have to be imaginary. So here's the process for going about figuring out what those imaginary roots are without factoring. So the first thing we do is we recognize that if it crosses at -3, we can let that be our root. And then we can use synthetic division with our coefficients here to be able to break this down into what we call a depressed polynomial. So let me work this out. Notice here I'm missing a cubic term, so I'm going to put up here 0x cubed. We are missing a linear term, so I'm going to put up here a 0x. Okay? So when I fill out these numbers, I would have 1, 0, -5, 0, and my constant's -36. I'm going to leave space there, leave a box to my remainder, and do synthetic division. Now, what is significant to know is that if you've done your math correctly, this should come out to be 0 as your remainder. If it doesn't, then you've made a mistake somewhere. So bring down 1, multiply, add, multiply, add, multiply, add, multiply. Great. So that means I know my work is right because my remainder came out to be 0. What we should recognize, though, is we started off with a 4th degree polynomial. So after doing synthetic one time with a linear divisor here, or if you can think about this, the factor would be x plus 3. If I divide x to the 4th by x, I get x cubed. So this is x cubed minus 3x squared plus 4x minus 12. But then all that does is leave another polynomial to solve. So what I'm going to do is keep this as my row, but use my other 0 and do the synthetic division again. So I'm keeping this row, I'm using my other 0, and I'm going to repeat this or do the synthetic division process again. All right. So this is what we created here was, we call it a depressed polynomial. In this case, it became a depressed cubic polynomial. At this point, when we do it again, it becomes a depressed quadratic. Now, what's significant about this is basically this is a quadratic equation, x squared plus 4 equals 0. Well, x squared plus 4 equals 0, we can use any quadratic method we feel comfortable with to solve. This is not factorable. However, because my linear term is missing, I can simply subtract 4 from both sides and get x squared equals -4. Then take the square root of both sides and get positive and negative. Don't forget, when you take the square root of x squared, we get positive and negative 2i. And that counts as your other 2 zeros because it's a positive 2i and a negative 2i. So up here in my answers, I'm going to have -3, +3, 2i, and -2i as my solutions. Now, I'll be real honest, it was a lot easier when we did this in class by factoring. So I'm going to show that method also on this video. So if I have x to the 4th minus 5x squared minus 36 equals 0, I know that I can factor it like I do any other quadratic trinomial because my degree here in the middle is half that of my first term. So 2 is half of 4. But I also know that there are 2 factors of 36 that I can combine to give me 5, namely 9 and 4. So I'm going to factor this. I've got one positive, one negative because my constant's negative. And I need a -9 plus 4 to give me a -5. So I've basically, as you can see, got the x squared minus 4 in one step just by factoring. We should recognize that x squared minus 9 is a difference of squares that factors as x minus 3, x plus 3. But this isn't necessarily factorable unless you recognize it that, again, if we set this equal to 0 and solve, we're going to get two complex roots. So I did show in class how to factor that, but we would still get positive and negative 2i. So therefore, x is positive and negative 2i, positive 3, and negative 3. But I've done it by factoring. So you can see that this is a lot shorter work. In fact, in class, I taught you that since it's a sum of squares, it would factor into x minus 2i, x plus 2i. So that would make it even shorter. But know that if you don't understand how to factor, if you're not capable of factoring it, because some of them you just can't factor, you'll need to basically find your real zeros by graphing in your calculator and use those zeros to do synthetic division. And when you get it down to a quadratic, use quadratic method to solve. So that's number 1. Next, I'll show you how to do number 2. On number 2, notice that number 2 is a cubic polynomial. Oops. It's a cubic polynomial. So again, first step, I'm going to graph it. So I have x to the third plus 3x squared minus 14x, subtract 20. And I know that because my degree is 3, I should have 3 zeros. Okay? So for number 2, I'm going to have 3 zeros. I know I need to find them. I'm going to see if I can find them in my calculator. Now, I put 0 and y2, so remember, finding them using your calculator, you find the intersection of your function with the x-axis. So I'm going to hit second trace 5, move it over here all the way over to the left, hit enter, 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 and I get negative 5. Perfect. That's awesome because it's an integer, and that's what I hope to get. Because if I get integers, then I don't have to do anything special. If I come over here to find the next one, second trace 5, enter, 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 I get an irrational number. If I have an irrational number, I cannot write it in factored form, I cannot state the 0, I cannot just convert that in my calculator. So that means that to find the other two irrational roots, I'm going to take this negative 5 and do synthetic division, making sure that I have all terms in descending order. So I've got cubic, quadratic, linear, constant. So I'm going to have 1, 3, negative 14, and negative 20. So understand also that because we got irrational roots, that means it would not have been factorable. So leave some space, box for your remainder. 1, negative 5, negative 2, 10, negative 4, positive 20, and 0. Now because I started off with a cubic polynomial, this is now quadratic. This is x squared minus 2x minus 4 equals 0. Because I know I get irrational roots, as evidenced by my zeros in the calculator, I know that I can't use factoring to solve this. I'm going to need to use the quadratic formula. So, quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times 1 times negative 4, all over 2 times 1. So I've already got negative 5. I know I'm going to get two irrational. My job's just to do the math to find them now. Now remember I taught you to just do the discriminant in your calculator, the b squared minus 4ac. So I'm going to type in negative 2 squared, oops, not like that, minus 4 times 1 times negative 4. And we get 20. So that's our discriminant value. It's the part under the radical. So you're almost done. You just need to simplify the radical and reduce this if possible. So 20 breaks down to 4 and 5, of which 4 is a perfect square. So this is 2 plus or minus 2 square roots of 5 all over 2. Remember I taught you to take these three numbers on the outside, and if they have a common factor, reduce. So 2, 2, and 2 are all divisible by 1. So I get 1 plus or minus understood 1, square root of 5, and I do not need the 1 in my denominator. So that's my answer. I have 1 plus the square root of 5 and 1 minus the square root of 5. But it is perfectly acceptable to write them together. So I'm going to just take these answers. Well, actually, I can just come down here. X equals and put negative 5. And there's my 3 answers. So just keep in mind, you want to first graph it, identify any real rational zero, write it down as one of your solutions, then use synthetic division to find the rest. Now let's try 7. On number 7, you've got x cubed minus 1, and I'm just going to go just do this because we're going to end up needing to use division, plus 0x squared plus 0x minus 1 equals 0. Well, when I graph this, so let's first graph it. We know we should get 3 zeros. Let's see what happens. X to the third minus 1. So it looks like I only have 1 0, and it appears to be 1. So can I verify on my table? Yes, there's the order pair, 1 0. So I know that of my 3 solutions, 1 is one of them. Okay? I'm going to use that 1 in a box and use synthetic division to break it down to a quadratic. Once I break it down to a quadratic, I'm good. So 1, 1, 1, 1, 1, 1, remainder 0. So basically this is x squared plus x plus 1 equals 0. At this point, because when I graph it, I only see it cross one time, my assumption is that the other 2 are imaginary. Okay? Remember we had talked about that. You've got 3 total. You can have 1 real and 2 imaginary. Because it only crosses once, I'm going to have 2 imaginary. So that means I'm going to use the quadratic formula. So x equals, your a is 1, b is 1, c is 1. X equals the opposite of 1, plus or minus the square root of 1 squared, minus 4 times 1 times 1, all over 2 times 1. So if we put this in our calculator, 1 squared minus 4 times 1 times 1, I get negative 3. This is where it's really important to recognize that if you have the square root of a negative, you're going to use I. So that means I've got negative 1 plus or minus I square roots of 3 all over 2. And those are my last 2 solutions. Keep in mind that that means you have negative 1 plus I square roots of 3 over 2 and negative 1 minus I square roots of 3 over 2. So these are your 3 solutions. But know that it is perfectly acceptable to leave this as 2 solutions written together. So if you write that as your answer along with 1, you're good. So again, graph them, identify your real, use synthetic division to get it down to a depressed quadratic polynomial, then use a quadratic method to solve. Let me see if there's another one I wanted to try. Let's go, if we look back here at the second page here, let's do number 11, because I'm sure y'all would ask about that if y'all were in class. So on number 11, I've got this really long polynomial, so of course our first step is to graph it. All right, I'm going to graph it. And oh my goodness, I only have 1 real 0. And it looks like it's negative 2. So negative 2, 0, sure enough. So for this long polynomial, I have to have 5 solutions, and one of them is negative 2. So I'm going to start off with negative 2 and use 1, 2, 11, 22, 24, and 48. Alright, so at this point, because this is degree 5, I have 1x to the 4th plus 11x squared, because I don't have, that's my cubic term. So 0x cubed is 0. Plus 24 equals 0. Now, at this point, we know that we should have 4 imaginary solutions. Okay? So this is not going to be, actually this one is factorable, because if you look at its form, you've got 2 being half of 4 for your exponents, and you do have 2 factors of 24 that combine to give you 11, and that would be 8 and 3. So I'm going to factor this as x squared plus 8 and x squared plus 3. So keep in mind, that's because x squared times x squared is x to the 4th, 8x squared plus 3x squared is 11x squared, and 8 times 3 is 24. At this point, I set each of these equal to 0 and solve. So x squared equals negative 8. And this one, you're going to get positive and negative 2i square roots of 2. And here, x equals positive negative I square roots of 3. So these are all my zeros. Positive and negative 2i square roots of 2, positive and negative I square root of 3, and negative 2. So if you've got a large degree like 5, and you only see one real, you're probably going to end up factoring what's left, because you can't do synthetic division again because you only have one real rational root. So I hope that helps, guys. Message me with any questions you have. Whew. Got through a few. All right. All right, your warm-up is posted. We have a lot to do. Lot. All right, let's do it. Well, I will make sure that's confused. I promise. Yeah. Or science for college today in the library. Can I go? You can. I should be back in like 20 minutes. Yeah.
Really?
Alright, your warm-up is posted. Please go ahead and get that down. See if you can find the other zeros. We're going to write